Hello, welcome back to More Fun Fixing It. I'm Lee and we're going to fix a Spectrum today. This is one again from a previous triage episode. When the computers come in, I like to look at them, give them a quick triage, make sure that they aren't just not working differently. Wow, that's a different way of saying broken differently. Broken differently is when you think they're broken and they end up working. I had the last machine on my workbench was a toast rack, which was supposed to be broken. It was broken. You've seen this in a triage episode where it had a purple border and it looked like the CPU was at fault. I put it on my workbench ready to fix. I found that there was no clock there, and whilst I was probing around, it sprung to life and it's been working ever since. Probably just the capacitors that needed to be reformed, and it just works again. So it didn't make it into a public release video. It did make it into a Patreon exclusive video, and if you'd like to sign up to my Patreon, you can sign up to the free tier. There's no pressure to pay anything for it. The free tier will give you access to small videos like this where they're not full releases and other weird stuff. That's how you sell that weird stuff. So this one, again from a previous triage episode, is gets hot, beeps when press keys, comp mod. So it needs a comp mod, but we looked at this and I worked out that IC21 was bad and the DC-DC cap gets hot, and it's an issue 3B. Oh, it's got a new membrane in it, that's good. What else? It's got a -7 ULA. It has been upgraded to the DC-DC mod. So yeah, this is the cap that I said was getting hot. This one here I showed was getting hot on my thermal camera. Let's actually start the whole process again and do it by the book. So the first thing to do is to check for resistance. So here's a handy multimeter that I prepared earlier. And let's start with, ouch, I just stabbed myself. Let's start with the voltage regulator, make sure that that is behaving. That's the input side, is the lower pin here. 3 meg, fine. And the output side is over 1K, that's good. And then the 3 voltage rails on the lower RAM chips here need to be measured. So keeping the black lead on the ground. Pin 1, I can never remember which ones are which. I'm going to say pin 1 is 12 volts, and that's not shorted, so that's good. And pin 8 is probably -5, and 2.6K, that's good. Pin 9 is +5, and that's 1.1K, that's good. And then pin 16 is ground, and that should be dead short. That's all good. The next thing I'd like to measure is the coil. So these two here should be shorted, and these two here should be shorted. They're the ends of the windings, and these are across the windings. And if you've got a bad coil that has melted in some way and the insulation is broken down and there's a dead short here, then, or a lot of resistance, then you need to replace the coil. And this one is open, so that's good. And this one is open as well. Sometimes if you have the leads a certain way round and they're putting some charge through the coil, you'll get a reading like this where it goes up into the mega ohms. But you can just ignore that. Just change your leads around the other way round, and it should, after that charge has disappeared out of whatever it's gone into, go back to open loop. Now the other thing that we need to check are these transistors down here, TR4 and TR5, and one of them is actually in a tricky position. I'm going to show you this. Before we get stuck into this project, I just want to take a moment to thank the sponsor of this video, PCBWay. If you've been working on electronics for any amount of time, you've probably already heard of PCBWay. They are the go-to service for high-quality PCB fabrication. Whether you've got a simple design or something more complex, they can turn it into a reality with incredible precision. But it doesn't stop there. They also offer full assembly services. That's right, you can get your boards made and assembled all in one place. No more worrying about sourcing components or finding assembly services elsewhere. PCBWay takes care of it from start to finish, ensuring everything is soldered and tested to perfection. The best part, they do it all with an incredibly fast turnaround time and at very competitive prices. So whether you're working on a small project or scaling up, PCBWay's got you covered from the first design to the final product. Want to get started on your own project? Head over to PCBWay.com for an instant quote and see just how easy it can be to bring your designs to life. Thanks again to PCBWay for sponsoring this video and supporting the retro tech community. Cheers! So TR4 is here, and normally, in fact, I'll show it on this side. TR4 is here, these 3 points here, but this leg here is not there. That one is actually, this lead here from this cap is in the position where that goes to. And they've stretched the leg to a different position. And in the triage episode, this caught me out. So if I go into diode mode, I always start with the black lead in the middle. I was measuring, well, let's do from black lead to the top connection here is open. And I was measuring to the bottom one here. Oh, that's open as well. Or maybe it was the other way around. So that's good, but the top one, with the red lead in the middle, the top one is also open. Oh, I'm on the wrong mode. Right, so with the black lead in the middle, oh, that's the red lead. I'm tangling my leads up here. This is going well. Right, so with the black lead in the middle of TR4 and the red lead on the top, I get nothing. And if I go to the bottom, I should also get nothing, which I do. But let's just check over there. And with the red lead in the middle and the black lead on the top, I get 0.6, which is normal. And then the bottom one, I should get the same. And it says 1.15, but that's because that capacitor is attached to it. If I actually go to the correct point, I get 0.6. That is a normal reading on that capacitor. So, and TR5, 0.7 that way, 0.7 that way, and it should be open this way, and then 1.2 or 1 point something, yeah, 1.24 that way. That's normal. So that lets me know that this is all safe to switch on now. So I put it back in its case. I will just connect up my Super Henry instant composite mod, because it needs a composite mod. This is still connected to the RF modulator. Now, my favorite diagnostic tool is my Steam Card Pro by Dave Steamy Briggs. And let's switch it on and see what it does. Let's switch that on. Right, here we go. So it is running. And whilst that's running, I'm going to get the thermal camera and point it at this cap. It's best to say this one shows it quite clearly. That cap there is lighting up, and it actually feels warm. 33 degrees is not that warm, but yeah. And the diagnostics has come back with IC21 as faulty, which is that one. Does that? Which is not showing any different temperature on the thermal camera at all. IC21 is that one. Why is my finger so cold? My God. Anyway, leaving aside my terrible circulation, I mean, that's not ridiculously hot, that cap, but I think it would be a prudent move to recap this board as well as do the as well as replace IC21 with a chip that works. That's a 22. That's got to be a 4.7. That's got to be a 1. That's a 1. I'm going to make a map. My quick crude drawing here of the board layout with the polarity of the caps and most of the values. I can't verify that one, and that one, which I can't see because they've turned them around when they've installed. And these ones I know, but yeah, these ones are completely the other way around. So I'll pop them out and find out what they are and write it down. There are also maps available online. You can find them on Retroleum. But the reason I've drawn this one out is because it's got the DC-DC mod, and I wasn't sure what this cap was here. All right, I've got a new toy to play with today. This is a different desoldering station, and you'll be seeing this on my channel. On the main channel, I'll be making a video about that and comparing it with the Hacko and the ZD915. That's going to be interesting to see. Right, the next job that I like to do is mark the positions of all of the caps with a Sharpie. Yep. This one. And I think that one. Yep. This one. This one. This one. This one. Yeah, this one. And this one. I am just gonna give the each point a little dab of fresh solder to make sure that everything flows nicely and I don't damage anything. And also straighten up the end of the legs of the capacitors as well, so that the desolder station doesn't struggle too much. They're not too bad actually. Right, first time I've used this in anger. Let's see what it does. Well, it's got quite an urgent pump on it. Let's start with the easier ones. Oop. This is another one of these boards where there's not actually much lead to get the nozzle around. It's an angry cow. Doing a pretty good job so far, I think. It's a good test for it up here. These ones are okay, but the last one on these two caps is a very difficult, heavy blob of solder mask. Oh, not solder mask. Ground plane and solder. So this one is the really hard one. Oh, that's done a very good job. Even the Hacko struggles with that sometimes. Okay, all right, so let's get that one out of the way. Find out what this one is. This is 4.7, as I thought. And this one should be a 20. Oh, no, this might be a 1. Yeah, 1. That's the reset cap. 1. This one. And a 22. Right, got my map. I can just whip all of these out now. What did I get? Ah, this one I've not desoldered properly. Yeah, that's actually done a really good job. I'm quite impressed. Get some new caps. Right, so with the values on top this time. a much more useful way of doing it. Oh, this is a good idea. Here comes my new good idea. Speaking of new toys, I've got this. Is this going to be enough to hold this? Should be. Nice. Yeah, that's pretty good. Like it. So, 22. This is where I just want to flip it. Right, this one is in a smaller package footprint, so I'm going to have to just bend these straight down. Good. The only thing I need to do now is put a 22 in where this one was, and I'll use the original bit of sleeving as well. There we go. It's as bad as new. Right, see if we've not made it worse. Still works. Yeah, that capacitor is no longer getting hot. Okay, an IC21 is still failing, so let's pop that out, composite mod this, and then get on with it. 21 is this one. Everything's cut off short on this board. These legs are short as well. Not very fair test for this desoldering station. I have to say, that's done a really good job. I don't think it's going to be coming out straight off the bat without a bit of heat, hot air to loosen it. But even the Hacko struggles in that regard. None of those are really loose. It's not far off. I'm not going to force it, obviously, but I think if I did give that a little gentle crack, that would probably come away without damaging anything, but it's not worth the risk. There is some solder blown through as well. Right, I've got my Pico DRAM tester here. I'm powering it off of the Pi Pico just to see what it does. Right. 4164. 4164. Oh. What are these rated at? Rated at 200. That's passed. 15, 16, 17, 18, 19, 20, 21. Oops. Oh, Lee. Let's put that back in there and pretend that didn't happen. What a muppet. Look, that's fit straight back in there and no one will ever know. Don't tell anyone. How many of you were screaming in the comments, "You're taking the wrong chip out"? This is all an act. The mistakes are staged and choreographed. Okay, so it's the next one along, and I've got to straighten all of those pins now as well. By the way, I've updated the firmware on the Pico DRAM tester from Tube Time, this thing, and it's got some quality of life improvements, and I think some it also can test that the upper RAM in this. In fact, that passed. That I just tested that as a 4164, not the whatever this is, 5432, which is half bad. That tested good on both halves. That's it. Oh, that was very lucky because I might have not have picked it up straight away, but I might have picked it up after putting the Steam card back in and it was still testing faulty. Interesting. So the reason I just upgraded the firmware on this was to get access to the 4164s, but half bad. Yeah, I think it's 4132 stacked. There's some extra options on here. I'm not sure which ones are which, but yeah, we'll find out in a minute. Let's take the right chip out. Okay, same trick as before, but this time on the right chip. I'm not going to try and pull that straight out. Well, this shouldn't matter whether I test it on 4164 or the other thing, so let's try 4164 first. Failed straight away. But what is it? I think it's going to be, yeah, so whether it's 4532 XXNL3 or 4. Nice, this is very good. NL3, so NL3 is this one. Still failed. Wonder if the other half is okay. No, bad chip. Right, socket time. Oh, we also need a chip. Isn't it funny how you put a socket in when you change a chip, but I've put that chip back and I didn't put a socket in. Should I have put a socket in for a chip that was already in there and happily working? I don't know. Seems like a bit of a waste. Oh. Got quite hot. Okay, this is the good one. Yep, 4164. Very good. Let's try it on a faster speed. What is this rated at? This one is actually rated at 150 nanoseconds. Yeah, it's failed on that. The timings on the test are definitely tight. But 200 nanoseconds is plenty fast enough for a ZX Spectrum. Right, is that it? Is that everything that this needs doing to it? Hey. that's working. Right, last thing is quick composite mod, and then let's play a game. Lovely, and keyboard. Yeah. I can't really see what I'm doing here. I can't see the screen. I'm doing this mostly by memory. There's a big red line across the screen and resolutions and things. Anyway, that's just me showing how good I am. Pro gamer. Right, that one's fixed. I'll put this one back together. Right on there what it's had done. It's a nice little machine, an issue 3B with a DC-DC mod, and the caps changed. A good -7 ULA. This one is a keeper. I like an issue 3. Yeah, good machine. Thanks for watching. Don't forget to like and subscribe, YouTube things, and I will see you in the next one. I'm loving my camera here. Look at this. Why is that colour? Right. See you next time. Bye.